Okay, the penultimate video, mean value theorem. We are going to define something called an antiderivative. And let's start with a mathematical definition. Capital F, uppercase F of x, is an antiderivative of f of x if the derivative of uppercase f is equal to the original function. So the derivative of an antiderivative is the function. The usual caveats for all x in the domain of f of x. So a function is an antiderivative if the derivative of the antiderivative is the function. Whew. Let's do an example. I'm going to move to the next page. Let's do the example. Need room. Oh, for Pete's sake. Then pen quits working. Technology is awesome. Hey, there you go. Now you got to listen to me sing as well. Aren't you glad I'm a math teacher? Dropping something from a height 0, therefore into a pit. And we know that the acceleration of gravity is 9.8 meters per second squared. We're told that the initial velocity of this item is 0. So we're basically just holding it out and letting it go. And of course, since the height is 0, that means that the initial position is 0. So what do we know about acceleration and velocity? Well, we know that acceleration is the derivative of velocity. Velocity. Well, what this means is that velocity is an antiderivative of acceleration. Acceleration is the derivative of velocity, therefore velocity is the antiderivative of acceleration. So what do we know? Well, we know that acceleration is 9.8, and according to everything we've done over the past few minutes or past couple of videos, we know that the antiderivative of 9.8 must be 9.8t. Think about that for a second, plus a constant. So how do we find the constant? Well, we know that v of 0 is equal to 0. So this is 9.8 times 0 plus c is equal to 0, which means that the constant must be equal to 0 in this case. So we can write the equation of the velocity of this particle as 9.8 times time. Now, let's go look at position. We know that v of t is equal to the derivative of position, but this means that x is an antiderivative of v. So again, we can say that x of t is equal to, well, let's back up a step. X prime is equal to 9.8t. And now we got to be a little bit careful. I'm going to squeeze this in. I apologize for squishing this into the corner, but I wrote too big on the first step. So I'll try to be as careful as possible here. I know that x of t must be 9.8 times, well, the antiderivative of t is 1/2 t squared. So think about that for just a second. The antiderivative of t means that if I take the derivative of that, I will get t. Well, the derivative of t squared is t, except that it's 2t, so I have to put a half in front, plus some constant value. So since x of 0 is 0, I can plug in 0 for t, and again, I get that the c is 0. I'll leave the calculations as an exercise to you if you are not sure, which means that the function position with respect to time is equal to 4.9 t squared. Okay, so let's do a second slightly different example. This will just be part B. We're going to drop the item from the same height, but this time we're going to give it an initial velocity of 1 meter per second squared. And obviously meters per second, we're throwing it downwards. Acceleration as a function of time is still 9.8. That is, in fact, the gravitational constant, in case you hadn't recognized that. And we are dropping it from height 0, just like we did the last one. Now, why is this different? Well, the process is going to be the same. Acceleration is the derivative of velocity, which means that velocity can be determined using the acceleration. Velocity is an antiderivative, so when we work backwards, we discover that the velocity is 9.8 t plus the constant. Notice the difference now, though, is that we've got 9.8 times 0 plus that constant. The constant is equal to 1, and the equation of velocity is 9.8 t plus 1. Now, having done a better job of organizing my space, I have lots of room for the second half. I know that velocity is the derivative of position, which means that position is the antiderivative of velocity. Notice, derivative, antiderivative. So x prime of t is 9.8 t plus 1, which means that x of t is, well, again, we got 9.8 now. The antiderivative of t, well, t must go to t squared because I'm working backwards, but the derivative of t squared would have a 2 in front, so I have to put a half to balance that out. The derivative of 1 is just t plus a constant. And now I can plug in, since t is equal to, x of 0 is equal to 0, that means that this constant is in fact equal to 0, which means that the position function is 4.9 t squared plus t. And I have a function for position and a function for velocity for this object, which has been thrown downwards. All right, why don't you go ahead and do exercise 43 in the text. And I will be back with a recap of chapter 5.2. Thanks for watching. Hope you learned.